Welcome to qnawire.
All right. So for this problem, so we have a ball which is bouncing up with initial velocity v0, and we also have electric field which is pointing up. And we know that v0 initial velocity is 1.92 meters per second, and the magnitude of the electric field is 3.6 times 10 to the fourth Newton per coulomb. And the other condition is we know that the ball travel a distance of h equal 6.98 centimeters in t equal 0.2 seconds. So the question is, we want to find out let me see, we want to find out the charge mass ratio q over m. So to figure this out, we need to find out the velocity at t equal to 0.2 seconds. So to do that, we can utilize the energy conservation law. So the initial energy is the initial kinetic energy plus the potential energy stored in the electric field, which is EQ. Let's say this is just H. So this is the work done by the electric field, and this is the initial kinetic energy. And this will be equal to half m times v1 squared. So v1 is the velocity at a time t equal to 0.2 seconds, okay, plus the work done by the gravity, mgh. So we can solve for v1. We obtain v1 is plus or negative, let me see, it's v0 squared minus 2gh and plus 2e h q over m. Okay, so this means that we have two possible values for v1. v1 could be pointing up or v1 could be pointing down. So the two different values that will give us different results. Since we already have the value for v1, so we can utilize the relation v1 equal to v0 minus a times t, right? Because the acceleration is a constant, and the acceleration here, a equal mg minus eq over m, right? So we can plug this a into this relation, and we obtain equation plus or minus v0 squared minus 2gh plus 2e h q over m equal v0 minus mg minus eq over m times t. So in this equation, we know v0 and we know g. We also know the height h, we know e, and also we know t, right? So in this equation, the only unknown variable is the q over m. So we can solve for q over m by solving this equation. And because we have plus or minus here, so we have two solutions. For the positive one, we have q over m equal 2.72 times 10 to the negative fourth coulomb per kilogram. And so this is for the positive results. And for the negative one, it's negative 1.64 times 10 to the negative fourth coulomb per kilogram. So this is for the negative one, okay?